Hello everybody and welcome to another one of James's videos. Today we are going to deal with the type 3 grade 11 trigonometry special angles and reduction question. This is a more difficult question, or the exam level type question, should I say, where we've included quite a bit. We're reducing, we're using special angles, and we're also dealing with angles that are big negative angles and extremely big positive angles. So what we need to remember theory-wise, we need to know our cast diagram, we need to know our special angles and triangles, we need to know how to reduce, and we need to know our co-ratios. Okay, so the first thing that when we approach a question like this, what we need to look for is the red flags. Now the red flags in my eyes here are the angles that are not falling between 0 and 360. Okay, so remember, before we reduce, we need our angles to be between 0 and 360 degrees. So if they're falling out of that, guys, so if they're a really big negative angle, or if they're a really big positive angle, so greater than 360 and less than 0, then we need to bring it back into this range so that we can reduce it into regions that we are familiar with. So what we're going to do is we're going to just highlight those red flags. So this is a really big negative angle, right? And this is also a really big angle. Do you agree? As well as this one. So those are my red flags. So the other ones are all falling between 0 and 360, so they're fine. So what I want to do first, in my first step, is to bring these angles back into that 0 to 360 range. So what you're going to do is you are going to add 360 to the really big negative angles, and you're going to minus 360 to the really big positive angles. Okay. And just remember, guys, you can minus and plus 360 to these as many times as you want until they fall into this range of 0 to 360. Okay, so what we would get here is sine of 240. 240 falls between my range of 0 to 360. Fantastic. So my adding of 360 has done the job there. If I minus 360 from 660, that gives me 300. 300 falls between 0 and 360. This tan of 315 will stay the same. All over my cos of 310. Didn't have to do anything to that one. Didn't have to do anything to my sine of 140. And then my sine squared 410 minusing 360 from that would give me plus sine squared 50. Which is awesome. Okay, so by minusing the 360 from the 410, I've actually already made it an acute angle. So there's actually no need for reduction for this one because this is already acute. Okay, but these ones, however, we need to still reduce into their acute angles. And it goes very much similar to how type 2 question went in these the series of these videos. So sine of 240, I'm going to add this step in every time until everyone's comfortable. 240 is the 180 plus quadrant. So that's going to be 180 plus 60. I'm going to go a little bit faster just to get through the video faster. So cos of 300, that is the fourth quadrant, 360 minus, so 360 minus 60. And then your tan of 315. 315 is also the fourth quadrant, so 360 minus 45. All over cos of 310. So we've got cos of 310 is in the fourth quadrant, so it's going to be 360 minus 50. And we've got sine of 140, sine of second quadrant, so that's going to be 180 minus 40. And then the last one, remember, we didn't have to reduce because it was already an acute angle. Fantastic. Now we can go ahead and reduce them. So 180 plus is the third quadrant, so this will reduce to a minus sine of 60. 360 minus is the cos quadrant, so it reduces to a positive cos 60. 360 minus for this tan, that'll reduce to a minus tan because tan's negative in the fourth quadrant. All over, we're looking at the bottom one, cos, it's going to reduce to a positive cos because 360 minus is the cos quadrant. The next one is going to reduce to a positive sine of 40 because sine is positive in the 180 minus, and then plus sine squared 50. Okay, now what we can do, let's start to simplify. So now identities are also coming into play here, guys. Identities are general rules that we need to also remember, and that's also part of the theory-based video that I do in the beginning. So you need to know your identities as well, your basic one, but I'll explain now where that's coming into play. The top line I can change into my special angles, right? So the special angles or special triangles we need to remember is your 30, 60. So that's 1, 2, root 3. And then you've got your 45. Let's just give them angles. 1, 1, root 2. Okay, so sine of 60 becomes minus sine of 60, opposite over hypotenuse, minus root 3 over 2, times cos of 60, which is 1 over 2, times by minus tan of 45, which is 1 over 1, which is minus 1. Okay. Then cos of 50, sine of 40 plus sine squared 50. Now this is my indication of what I'm going to be looking for. Okay, so remember I mentioned in the previous video your co-ratios. If you have sine and cos and their angles add up to 90, it means they are co-ratios of each other. Okay, which means I'm able to change either this into a sine 40 or this into a cos 50. So looking at what we have already on this side, I am seeing, and I'm going to write it in yellow, sine squared theta plus cos squared theta equals 1. Guys, that is an identity. So if I've already got a sine squared 50, do you agree with me that it would make sense for me to make a, let's go forward. It would make sense for me to make a cos squared 50 on this side so that I can change the whole identity into a 1. So let's go ahead and change in this next step. Let's change the sine 40 into a cos 50. And I'm allowed to do that because they are co-ratios. So I'm going to put that step in. Times cos of 50 plus sine squared 50. Now that I've done that, let's see. We can do some simplification at the top here. Minus times a minus is going to be a positive. Root 3 times 1 is root 3. 2 times 2 is 4. So the whole numerator would simplify into root 3 over 4. Do you agree with me if cos 50 times cos 50 will give me a cos squared 50 plus sine squared 50? Order doesn't matter. Remember, these are both positives. So even if it was cos squared plus sine squared, it would still give me a 1. And that is the identity we were looking for. So now that whole thing changes to a 1. So now we've got root 3 over 4 over 1, which is just equal to root 3 over 4 as your final answer. Okay, so I'm going to put it in red here that I changed the sine of 40 into a cos of 50, and that was due to co-ratios. Okay, little note there. So there's a lot of things that we need to see with trigonometry, but like I said, the theory needs to be there. We need to know our co-ratios. We need to know our cast diagram. We need to know our special angles, and we need to know our basic reductions. But now also what we're including is we need to know our identities. Okay, identities are extremely important as well. I always say, James, my students always ask me, James, do we need to learn them or do we get given these things in the exam? So I said, guys, the moral of the story, if you want to do well in math, if you need a formula sheet, you haven't practiced enough. So that can be a nice little level or a nice little measurement on whether you've done enough before a test. If you don't need the formula sheet, you've done enough, because you can see. And as you can see here with these types of questions, you need to be able to see this stuff before you actually do anything, because you're like, oh my word, but I need to, seeing that that's a sine squared, that looks a little bit like this. But if you don't have this in your brain, then you won't notice that. Okay, awesome. Great, guys. So if you enjoyed this video, please scroll down, click the subscribe button so that you can get alerted to any new videos that come up onto the channel. And also, all these notes are available in the James book, which is for sale. So if you are keen, please drop a message in the comment section or contact us directly so that we can get you your copy of the James book. Fantastic. Hope you have a good one. Cheers.